My name is Muhammad Hanif bin Halim. My ID is 552141143992. Okay, today I will explain about the introduction of our mini project. The title is separation of ethanol and water. Separation of ethanol and water. Okay, the separation of ethanol, the differential solubility of sulfur in ethanol and water could be exploited to separate ethanol from water. The energy that could be produced by burning the separate ethanol would be more than required separation process. Okay, for the extractive distillation, the definition is distillation in the presence of a miscible, high boiling, relatively non-volatile component solvent that form no azeotrope with the other component in the mixture. The method is used for mixture having a low value of relative volatility. For example, the mixture cannot be separated by simple distillation because the volatility of two components in mixture is nearly the same. Okay. Next is the entrainer. The entrainer is the separating agent for this distillation process. Okay. That's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim bin Mas'ad, and now I will explain about process flow diagram of separation of ethanol and water by extractive distillation with salt and solvent as entrainer. Hi, this is the PFD of our mini project. Now I will explain the overall process of separation of ethanol water. The feed of this process is ethanol water. The solvent, which is ethylene glycol and calcium chloride, as a separating agent. Firstly, the feed will flow to the feed preheater to increase the temperature of the feed. Then the feed will flow to the dehydration column that contains ethylene glycol and calcium chloride as separating agent. The process of dehydration column will release top and bottom product. The top product release contain water, ethanol and ethylene glycol. For the bottom product, the product released is water, ethanol, ethylene glycol and calcium chloride. The bottom product is taken to the second recovery column, in which vacuum is applied in order to separate the water from separating agent, and the bottom product is recycled back to the feed preheater. Okay. The use of feed pump is to increase the flow rate of the solution. That's all from me. Thank you.
Oh, hello. My name is Muhammad Tarizi. I will explain to you about this material balance consists of 10 stages, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we start for stage 1. At this stage 1, the feed applied for this flow rate is 100,000 kmol per hour. In this feed flow rate mixture, it consists of 11 mole percent of water and 89 percent mole of ethanol. This flow rate will enter the feed preheated. At this preheated, this flow rate will be heated and will enter the dehydration column. It will continue into the dehydration column In this dehydration column, the flow rate will be split out to the top and bottom product. At the top, the flow rate will be 55,657 kilomole per hour. At the top, the amount of ethanol that we produce is about 99.6%. At the bottom, the feed will produce is 44,343 kilomole per hour. The other amount is water, ethanol, ethylene glycol, and calcium chloride, which is 0.242, 0.055, 0.676, 0.027. Okay, this flow rate will enter the recovery column. At the recovery column, it will split into two, top and bottom product. At the top product, the flow rate is 13,706 kilomole per hour. The product at the top is water, ethanol, and ethylene glycol. The main product here is water. So at the bottom, the flow rate is about 30,677 kilomole per hour. At this bottom product, the product is water, ethylene glycol, and calcium chloride, which is 0.0016, 0.96, and 0.03984. This flow rate will be same for stage 7 and 8 because it will one flow. So at this stage 8, it will add the pure ethylene glycol. The flow rate is about 570 kilomole per hour. So when it enter the stage 10, the flow rate will become 31,207 kilomole per hour because we add the flow rate from stage 8 and stage 9. The percentage of mole for water, ethylene glycol, and calcium chloride is 0.016%, 96.1% for ethylene glycol, and 3.8% for calcium chloride. So that's all. Thank you.
Hello, Assalamualaikum. My name is Adam Ipisan bin Mustafa. For this mini project of Semester 1, we will talk about the separation of ethanol. Why we use salt? Because salt have its advantage itself in solvent is that number of physical stage required for the separation and energy consumption are lower than the obtained in previous studies using only ethylene glycol as separating agent. The diminishment in energy consumption for the reboiler is explained by the effect that the addition of salt has on the mixture, since the quantity of solvent used is less than the one is used in the operation without salt. For the last, it is previously mentioned, the technology using molecular sievers presents low energy consumption, but it spends additional energy for distilled alcohol recycle generated by the operation. Additionally, ethanol obtained by extractive distillation with salt and solvent as internal is comparable with the former obtained by absorption with molecular sieves, and in terms of quality, taking into account that the content of ethylene glycol in the final product is lower than the minimum required, and the salt is not present. In this way, any hydrous ethanol produced by this method is suitable for several applications like chemical synthesis of esters, organic and cyclic compound chains, detergent, paints, cosmetic aerosols, or others. So that's all for me. Thank you.
Okay, Assalamualaikum and a very good evening to our beloved lecturer. Okay, so our title for this mini project is Separation of Ethanol and Water by Extracting Distillation with Salt and Solvent as Entrainer Process Simulation. I'm going to explain about how to increase the product which means the factor to increase the product. First, the effect of solvent to feed ratio. Solvent to feed ratio causes a direct effect on the distillate purity. Increase of solvent to feed ratio have an important improvement in the overhead product quality without considerably affecting energy consumption. Consequently, the reflux ratio must be operated in the lowest possible value, so the ratio solvent to feed ratio can be manipulated to reach the distillate composition without high energy consumption, and reminding that high solvent to feed ratio increase the energy consumption in reboiler of the generation column. A higher amount of solvent leads to a better separation compared to the one obtained with high reflux ratio, and it's also increasing the reflux ratio leads to the dilution of the solvent, diminishing its effect. High solvent to feed ratio are needed since a high quantity of solvent will make the dilution effect caused by high reflux negligible. Rising solvent to the feed ratio and reflux ratio increase the liquid flow in the column, and it will also increase the energy consumption. Second, the effect of salt concentration in the solvent. The advantages of using salt in solvent is that the number of theoretical stages required for the separation and energy consumption are lower than using only ethylene glycol as separating agent. Addition of salt, together with a low reflux ratio, does not lead to higher energy consumption that can save the energy consumption. Okay, that's all from me, Muhammad Azlan Shah Abdul Malik. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sulaiman bin Asmaun. Now I will conclude our mini project mass transfer 1. First, distillation process which is used is extractive distillation. Extractive distillation is a partial vaporization process. In the presence of a non-volatile high polypoint separating mass agent that is usually called entrainer or separating agent, which is added to the isotropic mixture to alter the relative volatility of the key component without additional azeotrope formation. In this case of study, calcium chloride and ethylene glycol are used as entrainer for separation of ethanol and water. The ethanol water mixture run into the feed preheater before being supplied to distillation chamber along with the separating agent. The top product are ethanol with 99.6% along with small amount of water 0.326% and ethylene glycol 0.074%. This can be said the ethanol extracted are almost pure as the amount of water and ethylene glycol as good as negligible. The bottom product are direct to recovery column to be recycled later. Finally, there are two factors affecting the productivity of ethanol. First is the effect of solvent and to feed ration. A higher amount of solvent leads to a better separation compared to the one obtained with high reflux ratio. Second, the effect of salt concentration in the solvent. The advantage of using salt in solvent is that the number of theoretical stages required for the separation and energy consumption are lower than using only ethylene glycol as separating agent. That's all for me. Thank you.